Hi students, this video is going to help you understand the shortest distance of a point from a given line. So you must understand, before you watch this video, you must understand dot product and its applications clearly. Otherwise, this might be a little confusing. So let us say an example is that if I wanted to find the shortest distance of the point 2, -1 and 3 from this given line. So what do you do out here? What should be your first step? My purpose is find out the shortest distance that I'm talking about, that is from this point to this line. And you know that shortest distance is gonna be perpendicular distance from any given point. Now, first thing that comes to your mind is that how do we go ahead about this question? Now what do you do is, you have been given the equation of line, write down the coordinate, general coordinate in terms of the parameter lambda. So that's gonna be this, it's your parametric form, nothing difficult. So basically this is your general coordinate of any point, so on the given line. So I'm doing is, I'm converting the vector equation in parametric form. Now, this becomes a general coordinate, and if I could get the lambda value for the point A, that's the whole job done. Now first thing what you're gonna do is, figure out the vector AB. So once you draw the vector AB is OB minus OA. So write down vector OB minus OA, which is going to simplify to this one. Now, you may pause a little time to do these complicated calculations. So it's just very simple. So put the coordinate of OB out here, put the coordinate of OA out here, and that's going to give you 3 minus 3 lambda, 2 minus -2 minus lambda, 1 minus lambda. Now, what do you do is, you're gonna take this vector is perpendicular to a given line. So if I take the direction vector of the line, which is 3, -3 and 1, and the dot product with AB, which is this vector, it should be 0. So that's what I'm doing. So if I equate this to 0, I'm gonna get the lambda value is 3/2. Now after this step, I'm not showing you the calculation because it's really easy. What I'm telling you is, just you're gonna plug this lambda value out here. So if you plug lambda value out here, you get the exact coordinate of point A, and then you can apply distance formula to get this distance, which should be around 0.93. Giving you another example to understand this. Let's say the line equation is r equals to -1 to 2, -3 and 1 plus lambda times -1, 1 and -1. What I want to do is, I want to find out the shortest distance of the origin from this given line. So first thing, again, you pick up a point, drop a perpendicular because that represents your shortest distance. You find out the general coordinate in parametric form. Remember that parametric form is just another way to write down the general coordinate. What I'm going to do next is find out vector OA. Vector OA is going to be coordinate of A minus coordinate of O, which is going to be, you can say position vector of A minus position vector of O, which is this all zeros. That's going to give you this. Now because you know that direction of this line is perpendicular to this vector, dot product must be 0. So I took the direction of the line and took the vector OA, which is out here, and I'm taking the dot product. Now once you take the dot product, this into this, this into this, this into this, multiply it out and equate to 0. That gives you lambda value as 2. Now once you get the lambda value, you're going to plug back out here to get the exact coordinates. That's going to be 0, -1 and -2. And again apply the distance formula to get the distance, shortest distance, as square root of 2. If you want to pause this video, you can pause it and reflect back on the calculation, or how do you check if a point lies on a line or not? This is the another objective of this video. So what I'm doing is, I'm taking an equation of a line, random line, and trying to see if this point is lying on the line or not. So the first step is to convert this equation, vector equation, in parametric form. Once you convert in parametric form, because this line contains the point, if it contains anyway, its x coordinate must be 2, y coordinate must be 7, and z coordinate must be 1. So what I can do is, I can solve for the parameter t. You solve for parameter t for all 3 x, y, z And if all these values are the same, the parameter values are same, then the point lies on a line. So out here, all the parameter values are different. Hence, the point doesn't lie on the line. So even the two of the values are same and third is not the same, you can just say that the point doesn't lie on the line. It's necessary condition for the point to lie on the line.